All right, so the power and product rules with positive exponents. If we have an exponent on the outside of the parenthesis, we want to do that first. And you also want to keep in mind that that negative sign in front of that x is really a -1. So I'm going to write it like this. -1 x cubed z to the 4th, and I want to square that. So keeping in mind when I square a -1, negative times a negative, that becomes positive. Then I'm going to get x to the 6th and z to the, not 4th, 8th. Thinking ahead, better put that, because I have to multiply my exponents there. I'm going to take that times my 2x squared y to the 3rd z, and so 1 times 2 is going to give me 2. X to the 6th times x to the 2nd. I'm adding my exponents, so x to the 8th. I have a y to the 3rd, no y's there. Just for fun, I'll put the y to the 3rd next. Z to the 8th times z. Again, I'm adding. 8 plus 1 would give me z to the 9th. So I have 2x to the 8th, y to the 3rd, z to the 9th. So on that second one again, because so many people mess up on that negative, put another one in there. If I write that as -1 x cubed y squared z squared, and I raise that to the 4th power, -1 to the 4th power is +1. If you want, you could put the 1 there. It really doesn't matter till the end, just so you know you did it. X to the 3rd raised to the 4th power would be x to the 12th. I'll get y to the 8th and z to the 8th. I'm going to multiply that by the -2 x cubed y z to the 3rd. And so when I multiply that, I get
-2
x to the 15th. Y to the 9th. And z to the 11th. So on that third one there, I'm going to do my squaring first on the outside. So this time they do have that number written there. It's -2. When I square -2, I get 4. And then I'll have x to the 6th, y to the 6th, and z to the 2nd. I'm going to multiply that by the -2 x squared y squared z to the 4th. So my answer would be
-8.
x to the 8th, y to the 8th, and z to the 6th. All right. So just watch that one, that negative is there. That's probably the most common mistake I see people do, is when it's an even exponent on the outside that they forget to make that positive. The next one is your rule for dividing with the same base. Your rule for dividing with the same base is to subtract your exponents. If I wrote this out the long way, u to the 6th w over u to the 3rd, w to the 4th, I'm really basically just canceling. So with my u's, I can cancel out 3 of them. 1, 2, 3. Leaves me 3 of them left over, right? With my w's, I can only cancel out 1 of them. Leaves me those ones on the bottom. And so I end up with u to the 3rd over w to the 3rd. So basically what you're doing is you're subtracting the smaller one from the bigger one, and your variable stays where you had the bigger exponent. So if I have b squared over b to the 5th, when I reduce that down, I'm going to end up with b to the 3rd, and it's going to end up on the bottom of my fraction. Cancel it out there. And if I have a squared over a to the 3rd, if I reduce that down, I get an a down on the bottom of that fraction. What's on the top of my fraction? The 1, because this is really 1b squared, a squared on top, and so that 1 is up there. So I get 1 over b to the 3rd a. So number 5, you may have some coefficients that reduce. In this case, we just have that 3. That's not going anywhere. It's still there. And I would have, what for my x's?
X squared.
X squared would be on the top or the bottom of my fraction?
Top.
Top. So x squared on the top, 6 minus 4 is 2. And on my y's, I'll have a y on the top. What's on the bottom?
1.
There's really a 1, but we don't need it. So we just end up with 3x squared y. So when you divide, you subtract those exponents. Evaluating expressions that have exponents of 0. If I'm going to end up with an exponent of 0, it's because I had something like x squared divided by x squared. My rule is to subtract the exponent, and when I take 2 minus 2, I end up with x to the 0 power. But we already know that if I take something divided by itself and I'm really just canceling, I'm saying, oh, this goes into here once and into this once. So by definition, anything to the 0 power is always equal to 1. Basically, it's canceling out whatever's there. So if I have 2/3 to the 0 power, oh, it equals 1. Here, if I have something in front that's multiplied by whatever I get for my answer there, but I have to do my exponent first. So if I'm evaluating this, I say 4 to the 0 power is 1. This is -1 times 1, which just gives me -1. Well, I really just end up with whatever's in front, because 1 times anything gives me what's in front. If I'm going to do -3/4 to the 0 power, what am I going to get for my answer? 1. Anything to the 0 power is 1. If I do 3 times 2 to the 0 power, my answer is going to be 3. 1 times 3 is 3. If I have -1 times 5, 6 to the 0 power, my answer is -1. Hey, I forgot to type my equal sign. And if I have 2 times -1/3 to the 0 power, my answer is
2.
2. I better fix. All right, evaluating an expression with a negative exponent. A negative exponent means you have to do the reciprocal of the base to make your exponent positive. So if I happen to have a fractional base, the reciprocal of 5/7 would be 7/5. That makes my exponent +2 instead of -2. Then I can square that. 7 squared is 49, and 5 squared is 25. So 7/5 squared is 49/25. So anytime I have that negative on the outside of my parentheses, I like to do the reciprocal of the base first instead of distributing out that negative exponent, just because life is easier that way. So if I'm simplifying number 11, the reciprocal of 2/3 would be 3/2. That's then going to be cubed, and if I cube that, I would get 27/8. And so 2/9 to the -1 power would be equal to 9/2. 9/2 to the first power, which is still 9/2. Part B then, now they give you an integer base where you have a whole number, not technically a whole number because some of them are negative, but I'm going to call it a whole number. That's why they refer to it as an integer. But when I do the reciprocal, I'm just going to put 1 over that value. So I'm going to rewrite this as 1 over -4 to the +3. Now on the Alex program, they won't put the parentheses around the 1 because 1 to any power still stays 1. So what's the point? But I like to put it there because I want to follow the rules. So then if I cube this, 1 cubed is 1. -4 cubed would be -64. Again, if you put it in that way, it's going to say it's correct. However, where should the negative go? In front of the fraction. And so that's how they'd like you to write it, is -1/64. And so number 14, if I do -3 to the -2 power, first getting rid of my negative exponents, the reciprocal of -3 would be 1 over -3. And then I'm going to square that. And so when I square that, my answer is going to be 1/9. Negative times the negative is a positive, so I get positive 1/9. And so if you do negative 2 to the negative 4th power, what do you get for your answer?
1/16.
1/16. Product rule with negative exponents pretty much looks like the product rule with positive exponents. My rules are the same. I'm going to multiply all the coefficients together, add the exponents, and then write using only positive exponents in my answer, so I'd probably get rid of those last. Multiplying this out, 2 times 7 times 4 must be like 56. And then I'm going to do my variables. If I have v times v to the negative 1, what would I get? I get 1 because v to the 0 power is 1. But when I take 1 times 56, it's still going to be 56. So I'm just going to cancel that out of there because v to the 0 power is 1 and I don't need the 1 there. If I have x to the negative 2 times x to the negative 4, I would get x to the negative 6, because I'm going to add them together. I'll worry about the negative in a little bit. And let's see, I did the v's, I did the x's, I didn't do the u's yet. U to the 7th times u to the negative 1 would give me u to the 6th. Now this one has a negative exponent, the x to the negative 6. What is x to the negative 6 equal to? 1 over x to the 6. So basically, if it has a negative exponent, if it's on the top of my fraction, I move it to the bottom. If it would be on the bottom of the fraction later on, we'd move it up to the top to get rid of it. So this answer then is going to be 56u to the 6th over x to the positive 6. And I just flip it down there and put it in the bottom to get rid of that negative exponent. So number 17, if I multiply 8 times 4 times 2,
64.
64, good, that's what I'm getting. I thought I was confused for a minute. So 8 times 4 times 2 is 64. I get v to the negative 2, because I have a 6 and a negative 8. I get x to the negative 4. And I get y to the negative 8, right? And that one, it happens that all of my exponents are negative. The 64, however, does not have a negative exponent. So the 64 is going to stay up on top, and the v squared, the x to the 4th, and the y to the 8th will all flip down to the bottom of my fraction to make my exponent positive instead of negative. I really didn't leave myself much room to write there, but I'll squeeze it in there anyway. If we multiply on number 18, 7 times 2 times 6. $84. And I'm going to get u to the negative 5, because I have 1 minus 6 is negative 5. X to the 4th, negative 4 plus 8 is positive 4. And v to the 0, which basically cancels out, so I'm not going to write it down. So my answer then would be what? 84x to the 4th over u to the 5th. Then that u to the 5th flips down to the bottom since its exponent was negative. Quotient rule with negative exponents. Our quotient rule says that when we're dividing, we can subtract our exponents. You could get rid of the negatives first by moving them to the opposite part, but since we just have that one operation, it's probably just as easy to subtract our exponents. So in this case, I would have x to the 5th. I'm going to subtract the negative 9, and when you subtract the negative 9, you end up adding it, so you get x to the 14th power, right? This really goes up here with this, and 5 plus 9 gives me 14. So if I take x to the negative 4 divided by x to the negative 2, I would get x to the negative 2. Negative 4 plus 2 is going to give me negative 2. I then have to rewrite it using positive exponents, so they would rewrite that as
1 over x squared.
1 over x squared. Now the same thing would have happened as if I would have put that down on the bottom, this on top to get rid of the two negatives and then cancel. But still would have ended up with x squared on the bottom of my fraction. So if I have x to the negative 8th divided by x to the positive 9th, what am I going to get?
X to the negative 17.
X to the negative 17 with rewriting it with a positive exponent. I get 1 over x to the 17th power then. The next I'm using my power rule. Again, I could get rid of that negative exponent first, but since it's only a one-step problem, it's probably just easier to use the power rule that says I have to multiply my exponents. And so 5 times negative 4 would give me w to the negative 20th power. Then I can get rid of the negative exponent by doing the reciprocal, so 1 over w to the 20th. You could have also got rid of the negative first and did the reciprocal of the base and then raised it to the 4th power. You end up with the same answer, so it really doesn't matter which order you do it in. Here, however, if I just multiply them, I get a positive answer, so that's probably the easiest thing to do. U to the negative 3rd raised to the negative 2 power gives me u to the 6th power. Negative 3 times negative 2, positive 6. And if I take x and I raise it to the negative 2 power, I don't know why they give you these weird ones, but they do. And then if I rewrite it in best form, my answer would be 1 over x squared. They really just think by now that you don't know that's the x to the 1st power? I don't know. So here, again, we're doing that power rule. Do you want to square that first, or do you want to get rid of the negative exponent first? It doesn't really matter. Which do you prefer to do? Square it first? Okay, so if we square everything, negative 3 squared is 9. W to the 4th squared is w to the 8th. And x to the negative 2 squared would be x to the negative 4. And we've got to get rid of that negative exponent, so we'll flip that down to the bottom. So 9w to the 8th over x to the positive 4 will be my answer. Now the next two have negative exponents on the outside. When you have that negative exponent with the coefficient, it's a little bit trickier. But do you want to get rid of the negative exponent first, or do we just want to raise it to the negative 2 power? Raise it to the negative 2. So if I do 4 to the negative 2 power, what is 4 to the negative 2 power? 1 over 4 squared, which is 1/16, right? So 1/16. If I do a to the negative 6 power raised to the negative 2, I would get a to the 12th. That's going to be on top because it has a positive exponent. If I have b to the 5th raised to the negative 2 power, I get b to the negative 10th, which means it's going to end up, instead of being on top, down on the bottom. Of course, they know you really don't need the 1. So a to the 12th over 16, b to the 10th is how that's end up going to be. Be gets a little trickier when you have that fraction and trying to figure out where everything is going to end up. So just for fun, if I would get rid of all the negatives first, instead of trying to think of, oh gosh, darn it, is it going to be on the top or the bottom? First I would start in here and say, okay, if I get rid of this negative, it's going to move that up to the top. So I'm going to have negative 2w squared x to the 5th raised to the negative 4th power. That makes it a little less confusing because I don't have a fraction anymore. On this one, you may still end up with a fraction. If I were going to get rid of that negative on the outside, I'd then do the reciprocal. 1 over negative 2w squared x to the 5th to the positive 4th power. So I've gotten rid of all the negative exponents, and so then I don't have to figure out while I'm working, is it going to end up on the top or the bottom? So 1 to the 4th power, still 1. Negative 2 to the 4th power is positive 16. W squared raised to the 4th power, w to the 8th, and x to the 5th raised to the 4th power. And so I end up with 1 over 16 w to the 8th x to the 20th. So if you are having a hard time with all the negatives and where is it going to end up, my suggestion is get rid of the negative exponents first, then go ahead and worry about doing your exponent. Hopefully everything ends up in the right spot.